This animation is about tissue fluid movement. I know you've done this before, but I want to revisit it because of its importance in the development of pressure ulcers. I'd like to pick up on a couple of the points in the etiology of pressure ulcer development as our starting point. These points in the cycle, pressure greater than 32 millimeters of mercury, decreased capillary flow, and capillary collapse are interlinked with each other and of course linked with McClymont's cone. First, a reminder of what normal tissue fluid movement is. Well, that's the movement of fluid and all the substances dissolved in that fluid, like oxygen, carbon dioxide, glucose, hormones and so on, from the vascular compartment, and by that I mean capillaries, to the interstitial fluid, then across cell membranes and finally into the cells. Don't forget the walls of the capillaries are a single cell thick to facilitate this movement of fluid into and out of the capillaries. There are two forces which come into play to move this fluid into and out of the capillaries. Those are osmotic and hydrostatic pressures. They coexist to maintain a dynamic equilibrium, which is absolutely crucial. Let's look at how this dynamic works. We have fluid being filtered out of the capillary into the interstitial space by hydrostatic pressure. Side by side, we have the osmotic pressure within the capillary pulling fluid back in from the interstitial space. It seems bonkers, I know, but it's simply necessary to accept that these forces work to maintain an equal movement of fluid into and out of the capillary. This is the means by which a constant capillary pressure is sustained, keeping the capillaries open and blood flowing through them. We therefore have a dynamic equilibrium maintained. But there is a problem when tissues are subject to pressure. You can see that if the pressure rises above about 32 millimeters of mercury, the capillaries with their single-celled walls are deformed and collapsed and simply cannot sustain a blood flow. If capillaries cannot fill with blood, there can be no hydrostatic or osmotic pressure to move tissue fluid and all the dissolved substances from the vascular compartment to the cells. Death of tissue, in this case epidermal, dermal, adipose or muscle tissue, becomes an inevitable consequence and the risk of pressure ulcer development that bit higher.